So we talked about this a little bit before of that when we talk about the definite integral, we're talking about the area under the curve. If my function f of x is a continuous non-negative function on the interval a to b, then the area under the graph of f of x, which is above the x-axis from x equals a to x equals b, is equal to the definite integral of f from a to b. So again, if we have what it means is non-negative, is that you have a function that is all above the x-axis. It may touch the x-axis at a few places, that's fine, but your function has to be above the x-axis. Now it could be like over here, so it could be where the x values are negative, but all the y values are either 0 or positive. And if that happens, then our area of our function from whatever our start is, like a to b, is just going to be the exact same thing as the integral. Now, if our function instead is not all positive, it goes both above the x-axis and below the x-axis, then the definite integral it gives us is called the net area. So the integral from our start to our finish gives us the net area. And so for the net area, any of the regions that are above the x-axis, the area between those regions and the x-axis are considered positive. But anything that where the curve is below the x-axis, the region between that curve and the x-axis, so this blue region, we consider when we're doing the integral that it's going to be negative. And so you could find the area, but it's going to be the opposite sign. It's going to be a negative value. And so we say net area means that anything when the curve is above the x-axis, we consider those positive. And then for anything below the x-axis, we consider it negative when we're doing the definite integral. And so we have to take into those signs into account when we combine our areas. So we would add up all the areas above the x-axis, but then we would subtract any of the areas that are below the x-axis, or consider this to be a negative value. So that's important to remember for that if they're asking you for the integral versus asking you for the area. If they are asking you for the area, then you are taking the absolute value of this section for the integral and then adding them together. So in this case, the net area would be A1, and then we would subtract A2 because we consider that section negative, and then we would add A3. So one of the homework problems is like this, where they give you the areas of the region. So they said A1 is 10, A2 is 4, okay, and they're considering these areas, and areas are always positive. So they're gonna give you all these values as positive, and then A3 is 2. When I take the integral from a to b of this function, it's going to be using this formula where anything above we consider positive. Okay, and you can do any order you want, but I'm considering these two positive, and then I'm subtracting any of the regions that fall below the x-axis. Okay, so this would give me 12 minus 4, which is 8. And so that would be the value for the integral of it. Again, if they just asked you like, what is the area under the curve, then you would consider this as a positive 4. And you would say 16. So for some problems, they're going to ask you, they're either going to give you a graph, or they're going to ask you to draw a graph and find the area or the integral based on areas. So if they say here, find the integral from, this should just be 0 because you can't really have a negative 0 to 9 of f of x dx. So we have, these are my x values. So I'm starting at 0, I'm going to 9. And I want to find this integral because this curve is completely above the x-axis. This integral is just equal to the area under the curve. And when we say the area under the curve, again, we always mean the area between that curve and the x-axis. And the easiest way to do this, instead of trying to figure out a function that you can integrate, is just to find the area. So I have a triangle. We know that the height of the triangle goes from like the vertex of the triangle to the opposite side and has to make a right angle. So this height would be 3. The base is perpendicular to it, so it makes it 90 degrees, and this base would be 9. And then the area of a triangle is like 1/2 base times height. So we would do 1/2 3 times 9. So this would give us 27/2. Okay, and you can leave it as 27/2, or you can make it a decimal of 13.5, whichever one you're more comfortable with. But that would be the area, and that area is the same thing as this integral. Now, some of them are going to ask you specifically to find the area under the curve using geometry. So this says find the area under each of the given curves, this curve 4x equals 2 to 3. So yes, you could possibly integrate it, but when it specifically asks you for the area, it wants you to make all of the regions positive. So if anything falls below the x-axis, you also need to make it positive. So in that case, you should always graph it either using your calculator or by hand. So this one is pretty easy to graph by hand. It's a line. The y-intercept is 0 because they don't have anything. And then the slope would be 4. So we go up 4/1. And I'm just going to have to move this down or I'm going to run out of room. And if you're not sure about that, you can again make a table X, Y, and then plug in like 0, 1, 2, 3. The main region we need is from 2 to 3, but it's good to get a bigger picture of the graph. So if I plug in 0, I get 0, and that's the y-intercept. If I plug in 1, I get 4. Okay, and again, that's like going up 4/1. If I plug in 2, I get 8. Again, if you were doing a slope intercept form, you would go up 4/1. And then 3, you would get 12, which is again up 4/1. Okay, my line's not going to be perfect because my scale is not perfect, but you just need a quick sketch to kind of get an idea of it. And so when we talk about the area, what we're doing is we're saying it's between this line and the x-axis, and I'm starting at 2. So I'm going to draw a line from the curve to the x-axis at 2, and then the curve to the x-axis at 3. And we want to find the area of this shape. Okay, and this one might not be as well known. This is a trapezoid. Okay. So again, you kind of have 2 options. If you don't know the area of trapezoid, you can do the integral from 2 to 3 of 4x dx. And because it's all the curve is completely above the x-axis, the area is just going to equal that integral. The issue is if it goes below the x-axis, then it wouldn't. You'd have to do a little bit more work. Or you could do a trapezoid. The area of a trapezoid is 1/2 HB1 plus B2. The height is the distance between the 2 parallel sides, so it's actually 1. And then the bases are the lengths of the 2 parallel sides. So we said this distance is 8 and this is 12. And then you would simplify that. So 8 plus 12 is 20, and then 20 times 1/2 is 10. Again, this integral would be 4x squared over 2. which simplifies to 2x squared. And then you plug in, again, always first your upper bound minus your lower bound. So this is 18 minus 8, which again is 10. So either way is fine. It's just if you're more comfortable with geometry or actually doing the calculus. Okay, and then one more, this is similar to one on the homework. It says evaluate the definite integral by interpreting in terms of areas. Okay, so this time I do want the definite integral. I don't want the area, I want the definite integral. So again, that means the net area. Because they said in terms of areas, and if they ask this on the exam, then that's where you should be drawing the graph and finding out what it looks like. So again, you can make a table. You mostly need 2 to 5. It doesn't hurt to like start at 0 if you want, or start at 1 at least. So if I plug in 0 to this, I'd get -6. If I plug in 1, I get -4. If I plug in 2, I get -2. I really need kind of our start and end, but if I plug in 3, I get 0. If I plug in 4, I get 2, and if I plug in 5, I get 4. Okay, this is the main thing that we do have to know. So when you're graphing it, you do need to know where it crosses the x-axis. You can always find that by setting a equal to 0, or again, using your calculator, find it. And so you get x equals 3, but you do need to know where the x-intercepts are, because that is going to determine how you do the areas. So then I'm going to graph this. Okay, so we have 0, -6, 1, -4, 2, -2, 3, 0, 4, 2, and 5, 4. And again, because my scale is probably not perfect, my line probably is not going to go perfectly through all these points that I drew. But not too bad. So when we are finding the area for this one, what we're doing is we are finding the area between the curve and the x-axis. So I'm finding the area of this triangle here. No, sorry, I'm starting at 2. So actually this tiny triangle here. And then I'm going to 5. So 5 was here. And then the area of this triangle above the x-axis. So it's always the area when you draw the region, it's always between the curve and the x-axis. And because it says definite integral, I'm going to treat this section here as a negative value and the section above the x-axis as a positive. So when I'm doing this, I'm really finding like the integral from 2 to 3, because that's where that y-intercept, or sorry, x-intercept is, of this 2x minus 6. And then I'm using the graph to find the integral from 3 to 5 of this 2x minus 6. So for this, again, you could calculate it by hand, but this question wants you to do it in terms of areas, and by hand it would be much faster to just do this entire integral. But what we're going to do is we're going to find the area of this tiny little triangle. So again, a triangle, the area is 1/2 base times height. So to find that, we would do 1/2. The base is 1 and the height is 2. So again, at 2 was -2. And we consider that integral negative because it's below the x-axis. And then we're going to add the area of this triangle. So this base is 2. And then the height, remember 5. We said the height here is 4, it goes up to 4. So that area is 1/2 2 times 4. And that's positive because it's above the x-axis. And so this would give us -2 plus 4, which is 2. Now, this is the definite integral, which is the net area. Just in case, if they asked you specifically for the area, then you do have to graph it. You can't just find the integral using our rules because it will give you the net area. So you would actually have to find the x-intercept by setting it equal to 0 and then split the integral this way. And you would make this one positive. So if they asked you specifically for the area, it would actually be 2 plus 4, which is 6. Because for area, we always consider areas as positive, and so that would give me the area of the curve, because what we're really doing is kind of flipping this over. So that's kind of the application geometrically of the integral, and if you have any questions, let me know.